Hello, everyone, and welcome to our Mechanical Engineering Meetup at AU 2020. My name is Anton Fedoseev, and I'm one of the hosts today. And my co-host today is Luke Michalczyk. Luke, can you introduce yourself as well?
Good morning, everybody. Good afternoon, wherever you happen to be. Thank you for taking some time out of your schedule. Hopefully, you find some value in this, and I think we're going to jump right into it, right, Anton? We're going to talk about some logistics first.
Yeah, let's jump into the logistic. All the lines are muted in general because the webinar is recorded and it's a big session, so we don't want to have too much of side noise. If you have a question, the way to kind of interact with us is to use the question box or raise your hand so we can unmute the link. And then the webinar is recorded, so you will get the recording right after. So in order to check the connection, let's ask the first question. If you don't mind, can you just type in your name and the city or the place that you're connected from, so we can quickly check the geography of this meetup, but also make sure that everything is working for you in terms of your ability to ask questions. And by the way, Luke, where are you connected from?
I am connected from beautiful Pittsburgh, Pennsylvania, and looks like we got Connecticut, Hungary, Kevin in Knoxville, Tennessee. Hey, Kevin, how are you? We just have tons and tons of people coming in. I can't even keep track of how many people are coming in. Let's open up that box. There we go. Yeah, we got people from looks like all over the planet, Anton. So I think we're doing pretty well. I think our question panel is definitely working today.
Excellent. Well, let's move on. So today's agenda, again, it's a meetup, so we'll have conversation, we'll have interaction, but we have kind of our discussion topics that we wanted to talk about, and we'll start about reflecting about this year, what happened, and the key reflections about COVID, tech highlights, community resources, and then we'll talk about skills going forward. The ones that we highlighted today are on the screen. And then at the very end of 90 minutes, we'll also talk about what's coming next. And today's panel is really large, and we've got great guests today. And why don't we start from quick introductions, like literally just say your name and role, and starting from Adam.
Adam Mentor. I work on the Autodesk community team.
I'm Andrew Ward. I'm part of the customer success organization.
Hello, everyone. Dan Szymanski, working on the Inventor team, located out of Michigan.
Hey, everyone. David Riem, working on the Inventor team as product manager for automation and factory design utilities.
Garen Gardner. I'm a product manager for Inventor as well. Work with both Dan and Dave, and out of the Portland, Oregon office.
Hey guys, Kevin Robinson, live from Cincinnati, Ohio. I look after the go-to-market strategy for Inventor and the product design and manufacturing collection.
Yeah, and we also have Lars. Lars probably stepped out or have on mute. Lars is leading Fusion 360 adoption team in customer success organization.
Right. And Tom Tremblay, just as it says, author and instructor.
Excellent. Well, welcome everyone. And of course, we have all of our amazing customers on the line. All right, let's start from the reflection. It's been a very long year. It kind of included the amount of events that it's suitable for 5 years, right? It's been a pretty challenging year, right, Luke?
Exceptionally challenging. I think that it would be probably not the right thing to do to ignore all the challenges that our customers have faced. Everyone on this line, I'm sure, has been in situations where one minute they were in their office and the next minute they were, teaching their children math and trying to do Zoom meetings at the same time. So I think that one of the big things that we have to recognize is that we're all learning and working in a different way. And I think these meetups, Anton, that you've put together have been a really good way of kind of keeping us focused on some things. So I think that was a really good idea.
But the interesting part is that the year started, of course, we heard about COVID, but it was not clear how serious it's going to be, right? And we launched Portal, a learning portal from customer success organization. We launched those meetups and everything. That it started pretty smoothly. We had no idea about what's coming next, right? We have this beautiful learning portal that I hope that you all can use or took a look at it. It has pretty significant amount of best practices and content that you can use, and also get even certificates of completion if you would like to, not like certify your knowledge, but to issue the fact of completion of some learning stuff. It was launched this year and it was pretty amazing. And then COVID happened. And this is, look, you and I, we had this big April program with lots of speakers in terms of transition to remote work. And like, can you summarize what happened? Like your take on that?
Yeah, so I think one of the things that I hope we did well, kind of looking back, reflecting on what worked well, was I think the responsiveness and timeliness. It would have been really easy to just put our hands up in the air and say, you know what, customers can figure this out on their own. But I think our response was really quick. As a matter of fact, we had the extended access program that ran for quite a few months so that individuals could access software. And then what we proceeded to do was host a series of webinars and events to help customers understand some of the different things that they might already have access to. So maybe it's something like just understanding how home licensing works. Maybe it's desktop virtualization or connecting with a VPN to be able to access your software. And I think that a really good example of this is something as simple as shared views. Whether individuals realize they had access to it or not, shared views allows you to collaborate, anywhere. You can create them at home. You can generate them right outside of Inventor. These things can be marked up and shared globally. So it was a really good example of something that you may not have ever used before, but when you get into this kind of different working situation, something that simple can really help you collaborate. So I think that's a perfect example of how hopefully customers were being able to leverage some of the tools they have access to collaborate a little better. So the next thing was some of the resources, and I just wanted to go through these really quickly. So we reviewed a lot of these in some of those webinars that we had. But the first three that you see there, these are just general Autodesk main resources. So if you just go to the Autodesk webpage, there's a banner for our COVID response, and it'll take you to essentially these three locations, and they walk you through relatively high level, working from home challenges and things that you can do to basically make things easier, better. And then the second set of resources that you see there, these are really specific for Inventor. We have a blog post that really pulled together resources from the AKN to different, webinars that we did, all in one location. So you can just go to that blog post, and it's kind of a soup to nuts location for everything you need as an Inventor user. That would need to be working from home or remotely. I put shared views in there because that's one of my more favorite things. It's just one of those great tools that you may not use a lot, and maybe you're using it a lot now, and hopefully you'll use it in the future. And then the last one for Inventor, there's this really awesome YouTube playlist. It's actually 14 videos, and it literally is all about remote collaboration and the challenges that everyone is facing. And then the last two, these are just general return to work for factory and production facilities and some office safety links. So lots of great resources out there. This is all available to pretty much anybody that wants them. So I'm sure these will be shared out as a part of the today's webinar. So yeah, great resources. Make sure you check them out, folks.
Yeah, and in any case, whether you are still thinking about what are some of the strategies to work from home or prepare your facility to the return, so we have pretty good best practices to consider. And we want to also give the control to you for a second. So why don't you reflect? And I wanted to ask our audience about, the changes on your side and what solution, what work setup did you get in the end? So please type in the Q&A. So we would like to know what's going on your side and what work setup did you end up having?
Yeah, maybe you were doing a VPN, maybe you were doing, Fusion Team, maybe you were using shared views, whatever it is, how you were working from home. If you wouldn't mind just dropping that in to the question panel, just so we can see those.
Yeah, and next thing that we wanted to talk about is some of the tech highlights, and this is where I would like to bring our engineering Inventor team to conversation. And Garen, why don't you share your highlights for 2021?
Let me unmute. So, there are a lot of things in there. When we were talking about this earlier, things that we really liked in 2021. And one of my personal favorites, it's not for everybody, either you need it or you don't. But, we've had more and more of our customers that want to be able to interact with construction or, other groups that they haven't been able to work with as much. And being able to directly read in a Revit file into Inventor is pretty awesome. I've been at Autodesk a long time, helped out with the early ADSK simplification workflow, a lot of the work that we've done with Revit and BIM. And this was a really cool one for me, just being able to find a Revit file, hit open, select a 3D view, and be able to open it up and have it associative. So if the Revit model changes, you can update that in Inventor. So that's one of my personal favorites.
Yeah, and the next one is Dan. Dan, what's your favorite thing in 2021 portfolio?
Yeah, so this is as the product owner for the Inventor team, working on a lot of customer enhancements and specific requests made for productivity and usability. This is really, it's sometimes the little things, we call them just do it's. This was just released last week and within our 2021.2 update, and it's just open file location. So you're in Inventor, you're working in you're switching between projects multiple times throughout the day, and sometimes you have maybe someone request a file, or want to do it like, where am I in this design? Where is this file reside on my massive hard drive or network? And it's just a simple right-click option, open file location. It just opens up Windows Explorer. It tells you exactly where you're at. If you're a Vault user, if you copied, you get latest, you've got the get latest, you've got this additional option. We delivered some other really cool stuff as well. I just wanted to focus on a small one. And these types of things, we delivered one for .1 with being able to configure your middle mouse button to pan, zoom, rotate. And also in .2, we delivered a new enhancement for being able to rotate your model within the part or the assembly environment, and to copy a drawing within itself. So those are just some things. So if you want to go ahead and progress to the next slide, I'll just share a lot of these items, as that last one was mentioned, was pulled from Idea Station, our Inventor Ideas Forum. Another great area to get connected is our feedback communities. We've got two great communities with internal communities for Inventor and Vault. We host them as beta programs. And this list here shows all the value. You can get insight as to what's happening. We post monthly builds throughout the year, where you can actually validate and play with the functionality as it's coming out to see kind of where our direction is heading with capabilities and enhancements. We post videos, we have webinars throughout the whole session to show you what the teams are working on, and just to obtain your feedback on getting your approval. Are we heading in the right direction? And then ultimately, we've got mechanisms within the beta community itself to let us know whether, with feedback, whether surveys or on our forums, to let us know. And we react to this feedback. We don't just say, okay, that's nice. We try our best to go down the path, and if we're going down a wrong direction, we want to know and make a course correction and make changes. So additionally, if you see a product flaw within your existing release software, you can always go through and log a problem report. And of course, enhancement requests. we are always looking for ways to improve the product. There's so many different areas, and there's many different forums, AU being one of them, for where we typically in person listen to feedback and collect that face-to-face interaction. We also conduct some events. Obviously, we've shifted to virtual this year within the Inventor team and the Vault teams, and we've conducted what we call our Inside the Factory. We had a summit just last month. So you would get all that information. So the 2 links here, we'd just love to invite you to the party to join. It doesn't end, it's always ongoing. So once you're in with us, you're a continual member, and you can kind of additionally see exactly what we're up to, and again, provide feedback on directions and capabilities that you'd love to see within the products.
So Anton, I think next time you have to make it specific. They're not allowed to pick their favorite highlight, something they worked on. Garen. So Tom, you get a chance to talk to lots of people that are going through training, and I'm sure that this last year has been maybe different for you. What were what would you say some tech highlights, things that really seem to resonate with you and some of the people that you were doing training with this past year?
Well, when it comes to the product, it's it's still just a continuation of just refinement. People are finding things that they've been looking for a few releases starting to show up, and what's fun to see is that especially having been around for quite a while, instead of it being big things, it's getting down to the point where it's subtler things that they're finding productivity in, little things that they enjoy, things that maybe they weren't specifically looking for are showing up, and they're reflecting that, gosh, someone's thinking ahead for me because I haven't even asked for this, and it's nice. So
yeah,
so it's nice to see the changes at that refinement level and quality of life level, I guess, rather than, gosh, I can't get my work done. That stuff seems to be that sort of thing isn't something I hear often anymore.
Yeah. One of my favorites is, and it's a quality of life, is the frame generator stuff this year.
Oh yeah,
it's just been the heads-up display alone to be able to like move stuff around and reposition it and rotate it was one of my favorites. So
yeah.
Hey Luke, that was my team as well. Just wanted to mention that. Sorry, I had to. I couldn't help it.
I should not have. I should have kept my mouth shut. Kept my mouth shut. All righty, back to you, Anton.
Yeah, and this conversation about Inventor and Vault communities for development teams, I wanted to bring another conversation, important launch that also happened this year. It's the launch of Autodesk Group Network. It's our new community program for everyone, and the role of community is so big these days when we're so disconnected, but connected virtually. So I would like to ask Adam Mentor, Senior Community Strategy Manager, to talk about this new program that was launched this year and about the role of communities in general. Adam.
Hey y'all, sorry my webcam isn't working. Thanks for inviting me to make a little informational plug as part of this conversation. I really love and admire the way this group is getting together to have these sort of peer-to-peer conversations and with each other about your software practices, which is really what the group network is all about. So the group network is a global network of user groups, developer groups, and online groups. Really, the goal is to enable you all to connect with each other, learn, build relationships, share your knowledge and practices. So what you're seeing here on the slide is a group finder that we have. I think we have over 150 groups in the network now, and you can find groups that might interest you by product or your location, the language, industry. It's a global network operating in multiple languages, and you can use this finder to dive in and go to the websites of the groups that you might be interested in joining. It's important to note that this program does include online groups and virtual groups, which was, we didn't realize how important that was going to be last year when we started it, but that's been a big push this year. Groups doing more things online. So the vision of the group network is to really help create a world where people are connecting in community. And Anton, you can go to the next slide. It's kind of got the group network's vision there. To share knowledge, and collaborate across firms and industries to improve the use of design technology and make a better world. And how the group network does that is the mission, which is on the next slide, which is to really support group leaders and to underpin that community of leaders with the resources that they need to manage their groups, grow their communities, connect and collaborate with each other, reach their personal and professional goals, and adopt new and better ways of working. And now I've worked in learning and community for Autodesk for quite a while, and stories I hear over and over again is the power of these types of groups to create relationships that can last lifetime, and to inspire people to do new things and to support people when they're having problems. So there's a lot of power in this. And Autodesk, the approach that we're taking with this program is we're not trying to control or own groups. We're just aiming to create deeper connections. And so we invite you, if these types of conversations are the types of thing that you want to do, in your local area, within your firm even, or based on something that you're particularly interested, to become part of the group network. And you can go to the next slide, Anton. This is the last one. Actually, we have a little poll here too. We already tested the question and answer thing, and I'm happy to help connect, test the poll. So we have a poll. Have you ever thought about leading your own meetup or online group community that we wanted to run real quick?
Yeah, let's do it. Launch the poll.
All right. So obviously not everybody is, we don't need millions and millions and millions of group. Not everyone can be a leader, but I'm seeing a fair number of people here saying that they are interested in being leaders, or are maybe interested now in being a leader. And if that's something you are interested in, we've started to put together resources to help you with that and create networks to give you support in that process. And I'll just leave you with a few final, there we go. We've got the results there. Thank you. And I'll just leave you all with the last slide so you can get back to your conversation, which is really, if you are interested in getting involved or learning more, you can add your group to the network, join a virtual group, just find a group. Or if you're interested in learning more about what's involved with starting a group, the group network actually has a project that we started this past year where we developed best practice guides for community management called the Autodesk Community Dojo. The link is on there, and I'll drop it into the chat as well. And feel free to email us at groupnetwork@autodesk.com if you have any questions or ideas or need some support. So thanks for giving me the time to talk about this new program. We hope it helps you all.
Perfect. Thanks, Adam. So what I'd like to do now is, even though he's from Cincinnati, don't hold that against him. I'd like to introduce Kevin Robinson. He's going to go through what he's calling key skills going forward. What do you got for us, Kevin?
Thanks, Luke. Yep, regardless of your Steelers affinity and my lifelong of Bengals and Detroit Lions pains from the two places I lived, you're still an okay guy. Good to be with everyone today. This session was really kind of just to stimulate a little bit more dialogue, a little bit more conversation, but just one note back to Adam's point. So way back in 2004, 2005 timeframe, I started a couple Inventor user groups here in the Great Lakes Midwest region. And I'll tell you, if you are even thinking about it at all, make sure you go and get involved in the Community Dojo, use that resource. I wish I had all of those resources way back in 2004 timeframe. And the community that I'm involved with today, and some of you are as well, is the Autodesk Inventor users on LinkedIn. So if anyone's on LinkedIn, just search for Autodesk Inventor users and you can find our group and connect with about 19,000, almost 20,000 people in that group. I do actually try to screen about 1 out of every 5 people who try to get in the group to make sure it looks and feels like they know anything about CAD or Inventor before we let them in. So if anyone out there is in the group and think there's people that don't belong in the group, let me know and we'll muscle them out. All right, so do I have any kind of control of the slides? Not sure. There we go.
Yeah.
So for this one, when we think about Inventor and the collection and life as a mechanical engineer, the Autodesk portfolio is huge. And today we're not going to talk about little features or feature workflows that like Tom or Dan mentioned or Garen mentioned to help. Instead, we're actually going to go over the math and the science involved in picking features. So here's the formula everyone needs to write down to make sure you understand how to contribute to future versions of Inventor. Okay, just kidding. But this was really a research project that Autodesk did. So if anyone wants to see the 75 pages with tons of math about how Autodesk does the next slide, is we have this new concept that we're using around called the learning graph. And this is something that, we as Autodesk want to help empower all of you to go deeper into the products. And so the learning engine is in beta right now. I forget all the products it supports, but this is just an example to give you an idea that, some of the skills we're going to talk about today are a little bit more higher level, not necessarily the nitty-gritty features that you see on the screen, but nonetheless, our researchers have 75 pages to prove we want to know every single click and pick and how to make you better at that. But we're not doing that today. Next slide. So really, the goal for all of us here at Autodesk and you as users of software is, at the end of the day, when you show up, these are the things that you want to help do. These are things that probably get you excited every single day to go to work. And these are things that your manager and your executives of your organization want you all to do. And so we handpicked a couple skills, but we believe likely many of you feel there are some skills out there today that we might not talk about that you think other mechanical engineers would care about. So as we go through the list today, if you have some of your own ideas about skills that we don't cover that you think are broad-based, put them in the chat and maybe another engineer will see them and get excited about them. So these are the 4 that we're going to cover: design automation, design for manufacturing, generative design, and collaboration. Next slide. And what we're going to do in these kind of like lightning round approach is we're going to cover like 10 to 15-minute chunks. We're going to talk about a topic. We're going to put some polls up to get some interaction going and allow you to ask any questions in the chat at any time. All right, so let's go ahead and dive in. So the first one's going to be collaboration. So some of my colleagues already talked about things like shared views, and that'll be one area that we talk about. Go ahead, next slide. So when we look at the landscape, this is a very clean perspective of everything that many of you experience, right? This is exactly how it all works. You have all your clean departments. Everyone, shares data perfectly, and you collaborate with customers and sales very easily. Well, next slide. I actually believe this is more what your day in a life looks like from a collaboration perspective. And we've done everything we can, where we keep trying to do everything we can between features and Inventor, what's available.
Hey, Kevin, I think we lost you for a few minutes there, Kevin, seconds maybe.
Cool. Am I back now?
You're back now. It was right before you were getting super excited about it. So go right back to that excitement.
Yeah, so I think, for all of us, we know this is the reality versus the clean slide. And many of you in your daily life have to solve collaboration problems in a lot of different ways. So this next section is just hopefully we can arm you with some new collaboration tools you're potentially not aware of. So let's go ahead and launch the first poll. This is be a fun little exercise around what you're doing for collaborations. So what collaboration tools do you use regularly? Email, phone, online meeting, Box, Dropbox, CAD-specific collaboration tools.
Forgot to add all the above, Kevin.
I did. I actually think potentially my poll might have been a little bit controlled.
I gotcha. I see what you were doing.
I had some other interesting, a little bit more jovial things, but we'll see how that pans out a little bit later. So, all right.
Let's take a look at the results.
We did let everyone do multiple answers. So obviously email, phone, online meetings, and a couple different ones. So to me, the most interesting one in terms of total volume was CAD-specific collaboration tools was the lowest total. So obviously it's a blended thing, but CAD specific ones were in the lower category. So the next couple slides and some topic might help.
Okay, so
okay, let's try design specific collaboration tools. So if you're in that category, what are the ones you do use? Now it's okay if they're not Autodesk related tech. We'll have a category for you, but we will take note and follow up with you after the fact with our sales team. No kidding. We aren't using this for any marketing materials. So we are using just good old-fashioned Windows Explorer with a viewer, some Vault, little shared views or Fusion team action, other Autodesk tech that just didn't fit on the slide, or non-Autodesk tech for collaboration. All right. So we captured most of them with the top two, and a little bit of shared views and Fusion team. Great, thanks, Anton.
all right, let's move on.
Okay, so here's the lay of the land. We're not going to talk about all of these today, and we're definitely not going to talk about any of them in great depth. But our colleague, Brian Shannon, who's not with us today, he's busy working on probably some other class or some other Q&A. We called him the godfather of Vault, like we call Mr. Dave Room, the godfather of iLogic, who's with us today. But Brian Shannon put together this slide and really talks about how we have a lot of technology that's wrapped around the Vault and connects with the Vault, or can sit independently. So everything that we show here can be independent or have a connection back to Vault, all right? So when we talk about things like shared views, there's a Vault connectivity and a standalone. Drive is a subscription benefit that you can use with or without Vault. Now I have a little indicator here of plus Project Sync for both Autodesk Drive and Desktop Connector. Those are some areas, I'm sorry, Project Sync between Drive and Fusion Team. This is technology that you can get that supplements your Vault environment and allows it to interact with some of these other workflows. All right, so this is just the landscape of a number of different collaboration tools. I'm going to talk about really two of them with a kind of a side order of Autodesk Drive and Project Sync on the next couple slides.
Yeah, and also to see like what of these tools are available to you right now, you can just go ahead to your Autodesk account, manage.autodesk.com, and see a lot of them, or maybe all of them are already available to you. Just, you know, never realized you have access to them.
Yeah, the one that probably won't stand out the most that a lot of people do have access to as part of their collaboration toolbox is Fusion Team. So Fusion Team comes with Fusion, and anyone who has the suites or collections all have access to Fusion Team. Or of course, if you subscribe to Fusion by itself, you have access to Fusion Team. Okay, next slide. So these are a couple things to kind of think about, and just curious if you were going to plug in into the chat or into the Q&A section, but like, you know, it's this tool set or all these toolbox options have changed dramatically just in the last 3 or 4 years. They keep getting larger and larger and larger. A couple of years ago, I made a spreadsheet that was all the Autodesk collaboration options, and I was like 13 different ones that you could choose from. And so there's a lot of there's no shortage of options for Autodesk. There's a lot of other options in the market. I'm just curious if anyone wants to chat in or chime in on the Q&A on how do you or how does your company decide what to implement within your organization? So any thoughts there would be really great. I'm curious, Tom, what have you been seeing at all kind of in your line of work? What are people doing with collaboration? How are they making decisions around which tools they might use? Any thoughts on that?
Yeah, the combination of AnyCAD and the desktop connector, in fact, I was just replying to a comment in the Q&A, is starting to get a lot of attention, especially with the people that aren't directly necessarily involved with the core engineering design of the primary product, who are maybe doing manufacturing, so they have to create the tool paths. Maybe they're using Fusion 360 for that, or doing some of the simulation using the Fusion 360 tools. They're able to use that link between either Vault and the desktop connector, or just directly dropping Inventor files into that localized version of the Fusion project. That's getting a lot of attention because now you're working with live data. and you've got that real handoff versus just a dump out a step, import a step. Oh, that's not what we need. Can you dump out another step so I can start my work creating toolpaths all over? That's starting to get people's attention a lot.
Yeah, that's actually one thing I'm glad you mentioned. I didn't have it in my slides, but AnyCAD is obviously a foundational thing around collaboration too. So just as a refresher, in case not everyone's familiar with it, but you know, in the Wayback Machine, we used to do IGES and STEP if you needed data from other systems into Inventor. Then over time, we had the ability to open and import other formats. And then over the last couple of years, it's really matured to this umbrella technology called AnyCAD that allows you to place another file from another system right inside of your Inventor assembly, and it's linked back to that. So if you get a new version of that file, it'll help in the collaboration. So I know Tim Harrison's on the line from Metro Detroit. You know, when he still had a real job doing engineering work instead of e-learning content, you know, a lot of times he was dealing with like CATIA files or NX files from an automotive OEM or tier 1 that he was designing some awesome machinery around. And constantly those things would change. So AnyCAD, if anyone is working with other formats, AnyCAD's a great way to take advantage of that. I'm not sure if there's any other interesting comments from the chat, if any of the other panelists want to bring up, but the other one that I'm just curious about is, you know, corporate perspectives around cloud are really different geographies around the world, depending on which industry you're in. And I'm curious, you know, if anyone has any thoughts that they want to put into the chat around, you know, what are you guys doing to still leverage cloud? You know, maybe you're leaning over the corporate rules a little bit. Maybe you've got 1 foot in, 1 foot out of the corporate rules to take advantage of some of the really important workflows. And then those that maybe have historically had a very definitive line around what's possible for collaboration. If you're familiar with Project Sync, the ability to have controlled PDM data and sync that to the cloud is kind of a hybrid approach. I don't know if anyone has any thoughts about that. So, Luke, I'm curious, you know, you've, in your role at Autodesk and also as the inventor, Luke, you've seen a lot of dialogue around these topics over the years. Maybe, is there anything you've been seeing come up around this hybrid, or maybe how people are banging the rules for cloud?
Yeah, it's interesting because I remember, you know, 10 years ago, before I joined Autodesk, I was working for Blue Ridge Numerics, and we were doing a lot of ITAR work. So this was that work that could never touch the cloud. It had to be in a room with a key, and, you know, it was super, you know, locked down. And, you know, I'll be honest with you, I think these perceptions are changing. You know, money. And you've all heard this analogy, but every dollar in the world is online right now in some way, shape, or form. And the same security that controls our finances controls our data. And I think, at least I've seen over the past 10 years, that this idea of putting our data in the cloud has become less and less of a problem. I mean, obviously, if you're, you know, a government organization, you might have something like that. But I've also seen a lot of people, I won't name any names because I think a couple are on this call, where they were doing it and their maybe bosses didn't realize they were doing it, and then they wondered why the project went so smoothly, and, you know, how are you able to do that? And it turns out it was using cloud collaboration. So I won't name any names because I'm pretty sure he's on the call. So yeah, I think that perception is definitely going down. So that's my experience, and I imagine a lot of everybody else's as well.
Well, cool. If you're on the line today and you maybe want to chat a little bit more about one of these questions and talk a little bit with kind of an extended crew, I mean, obviously reach out to your Autodesk reseller, use our discussion forums. But if you want to connect directly either in LinkedIn or email me, feel free. I'd love to talk more. So next slide. So just to touch on a few of the things. So shared views is a subscription workflow that allows you inside of Inventor, inside of Vault, and other Autodesk products, but we're primarily mechanical engineers and design manufacturing, but allows you to bundle up something that you have on your screen and publish it through the Autodesk viewer. That allows you to then share that link with other folks and collaborate on that visual representation. Now that doesn't stop you from taking advantage of the Autodesk viewer and just uploading files manually and doing some similar workflows. But shared views allows you to do that from within Inventor, from within AutoCAD, and from within Vault. And the nice thing from within Vault is you're actually grabbing the files from within a PDM system, and maybe you're searching for those files using the power of search and getting through all the metadata to find which files you want to collaborate on. There's a lot of interesting things once you're inside of the shared views environment of how you decide to collaborate. But the most important thing to me is you as a user, you as an engineer, don't really have to worry about a lot of the minutia it takes to get data in front of some other people to make a better business decision, a better design decision. So in the Wayback Machine, when we had to worry about things like the design assistant or pack and go, make sure links weren't broken, make sure project files are squared away. Potentially someone who was using the Vault viewer and they had to be within inside of the firewall. Shared views allows you to quickly get to others like customer suppliers in the shop floor on a one-off basis to get some critical feedback faster so you can keep moving. So if you haven't taken advantage of shared views, please look at it. And the next one, just to keep moving along in terms of the lightning round, I talked earlier about Project Sync, and I mentioned that Fusion Team was an entitlement and something that you had access to if you were a Suites or Collections customer. So I just wanted to kind of remind you that if you own one of the vertical Vault products, Workgroup or Pro, and you also have access to Fusion Team, using Project Sync in the middle allows you to connect those two. But the really powerful thing is it's done on lifecycle states and change states and categories. So 3 critical things that you do inside of your Vault to really control how information is shared. When you release a file, when you change the status to something like Collaborate, you can have it automatically push stuff to your Fusion Team site. And then inside of Fusion Team, you can go and invite all those same people. So same concept, you're trying to get to a decision and feedback faster with customer, supplier, shop floor, or contractors. The difference here though is it's controlled in Vault, so it'll make IT people a little bit happier and may make executives more comfortable with a straddled hybrid position. So this is kind of like a super form of collaboration integrated with data management. And if you don't have paid Vault and you just want to try a portion of this, you can still use Fusion Team and Desktop Connector to do a portion of this way to get data to the cloud without one-off things with shared views. So you have a lot of options between that wheel that we showed earlier and some of the things around collaboration. So that's what I wanted to do in the first part of the lightning round for collaboration. From a considerations perspective, Brian Shannon, who I mentioned earlier, and some other great folks at Autodesk manage the Under the Hood blog. So please check that out. There's a lot of great topics there. And there's a fantastic YouTube channel called The Vault Knows All that has a lot of technical clicks and picks videos of some of the things that I highlighted today. So those would be 2 great things that I would check out.
Yeah, and on Fusion Team, if you're curious about using Fusion Team and Desktop Connector, the workflow that Kevin mentioned, Brian Shannon recorded a course on Customer Success Hub that goes in great detail in terms of how to roll it out and how to use it. So another great resource. All right, so this is Desktop Connector. Kevin, do you want to?
I had that slide in there. I thought I hit it, but it's still an important slide while it's here. But this is just a quick snapshot of what Desktop Connector can do at a really very high level overview. This is what it looks like inside of Explorer, and you're mapping information to cloud drives. They do a hybrid approach between desktop and cloud.
Excellent. All right, so generative design, we moved it up because we know that Lars has to go a little bit earlier. So Lars, quick connection check. Can you hear us?
I can hear you guys. Can you hear me?
Yeah, we can hear you. So we first of all, thank you for joining. I know it's a very busy period of time for you. Quick question. We know that you recorded quite a few classes for generative design and generative design separately and for Inventor users. Could you say a little bit more about the work that you have been done recently for generative design and how it can be useful for more traditional, mechanical engineers and users of Autodesk Inventor?
Yeah, absolutely. So I'm sorry that I had a little bit of technical issues. I couldn't get my camera on, so I apologize for that. Yeah, so there's a couple of different things that I think people want to go out and check out when it comes from being an Inventor user and going to generative design. So just to make sure that anybody who hasn't really been on the generative design wagon. So generative design is a workspace in Fusion 360 that will let you utilize the cloud to go up and find new design alternatives. Not only just using AI to and cloud computing power to find some very out of this world kind of results, but also align it with the potential manufacturability you have on hand. So, like many times when we're looking at organic shapes inside of utilizing something like shape optimization or generative design, it's hard to figure out how you will actually make that part in the real world. But with generative design, you actually get the outcomes for standard manufacturing. So we're talking about 2D, so it could be water jet, it could be plasma. We're talking about standard CNC milling, like 2.5 axis up to 3 axis and up to 5 axis. You have 7 axis. We can potentially also attack that. Casting and other things. So generative design really gives you an opportunity to explore new design options. Now, the thing that we are aware of at Autodesk is that there's a lot of people who are using Inventor and are comfortable in that workspace and really good at it. And they should have the option to do a lot of the modeling inside of Inventor and then pass it over to Fusion 360 and generative design within that and have these calculations running and then come back in the cloud. So there is some different tutorials out there. There's, of course, if you go out to like YouTube or something like that, you can find a bunch of stuff there. If you go to some of the help content within Inventor, you will actually find also content there on how you prep your model inside of Inventor, and then how you can bring it, like I said, to Fusion 360 and utilize the cloud.
Yeah, thanks for the great intro. And let's dive in, and we have a couple of polls about generative design, and that's an interesting quote. Kevin, is it coming from you, right?
Yeah, well, not from me, but is my audio coming across? My camera looks like it.
Yeah.
Yeah, so one of our colleagues, Roger Orban, had a blog post a couple years back, and this was the title of the blog, and it really rung true to me. And I thought about my last 20 years in the CAD business is that there's always this like interesting measuring game and balancing game between being really good at tools and being a really good engineer. And so the whole premise of Roger's article is fantastic, and I think to me it really talks about, don't think about generative as just another feature. Think about generative as a way to be a better engineer. So we'll talk a little bit more about that. So next slide. And so, Lars is here today as one of our experts on generative design. I'm going to talk about a few things just to warm us up, see if there's any questions I've come across that Lars can answer via chat or add some more context to. But this is the kind of the corporate description of generative design. It is a technology inside of Fusion 360, but if you're on suites or collections, you have access to it. And we'll talk a little bit more about a way everyone can try it as we wrap up this section. But the whole intent here is that instead of doing one design, running it through FEA, you can combine things like simulation and manufacturing methods into your constraints to come up with a lot of different options. And so next slide, I'm just curious how many people are already familiar with generative design or have used it before. So we'll go ahead and load up a poll here. So have you used Autodesk Generative Design? We've got maybe a few yeses that'll come through, but maybe some people have just tried some similar tech. Maybe you're starting to look at researching and taking a little gander at it, or maybe it's just not relevant, or it's not perceived that it's relevant based on your current level of knowledge with it. So nice couple results there.
Let's see.
Interesting that we're kind of in the small categories for yes on a regular basis, but it's still an emerging tech. And a few people are in the no camp, but I love to see a lot of people actively researching that. All right.
This is great news, and we're going to the next slide.
So these are the visual support. This is kind of us telling the story that you're gonna have a lot of concepts as an engineer. You're gonna try to figure out during the iteration phase how you're gonna make it. You're gonna maybe use a great tool like shared views to collaborate with manufacturing. You're gonna do some FEA. Maybe you're gonna make a first run and test it out. And then you finally go to mass production. Well, the next slide is really saying, well, how can generative maybe complement that or move more of the iteration, more of the concepts earlier in the phase and give you a lot more options. So instead of doing just a couple of iterations because you only have so much time, so much capacity, and so much brain power to get through a couple of them, can we leverage AI, the computer, to get us more options? And that's really what generative design is all about, is to kind of give you more options and get to something that's manufacturable faster and obviously get to market faster. Next slide. So I wanted to highlight this because, when we think about a lot of the examples that people have seen around additive technologies and generative, most people, their first reaction is this kind of like bird bone science fiction shape on the left, right? These crazy looking things from prehistoric times, have no idea how anyone would make that. But this is a perfect example of one of our customers, Claudius Peters, took generative design, and even though they were not going to use additive and or metal additive to make the part, it helped inspire a new way to make their weldment and their assembly. So the next slide shows the actual differences by using the inspiration from generative to be able to reduce the weight between two different parts / assemblies, weldments that are being used in this context. So incredible reduction in total weight, but still able to maintain all of the performance needs that it had. So if nothing else for generative today, if my mission is only to create some confidence in you that it's not just about the science fiction bird bone and you have to have additive manufacturing to come up with a new way to have multiple design iterations early, and then hopefully that inspires you to make better parts, better performant parts.
Hey Kevin, while you're there was a question that came in that talks specifically about those organic shapes, and I was wondering if Lars, I see he's still on. I was wondering if you could talk about there's ways to restrict the way it's made. Correct, Lars? Could you just review some of those, because I do think there's this perception that it only does bird bone and that there's no way to get this to do a traditional, 3-axis or 2-axis or whatever axis CNC. Could you review some of those for that more traditional manufacturing process?
Yeah, absolutely. So, I mean, I think, Kevin kind of set it up, right? Like there's some things with generative that is really interesting. One thing is, of course, can we make our parts lighter? But I also think, as many of us as designers and engineers, there's a lot of people, we are kind of taking the same approach to solve the problems we are solving day in and day out. And having something like generative design available to kind of throw some of those components that you maybe already are manufacturing, send it through generative design to see what would you actually get out, and maybe just validate that what you're doing today is a pretty good solution, but it could be an interesting way to maybe troubleshoot also, how we many times, at least I know from my experience, have a tendency to over-engineer certain things. And the thing about generative, as to Luke's point, is that it gives you can control what type of output you want. And you can do that from a manufacturing type of approach. So like I said earlier, you can actually say, I only have a certain machine or certain types of manufacturing capabilities available to me. So I'm not going to look at what a potential additive or 3D printed part could look like, because I don't want to spend thousands of dollars on a metal additive printed part, or maybe I just want to look at something like that is 2.5 axis, so there's like prismatic looking part. Generative will kick those out to you, and you can get those results. But not only can you get those results you get those back as actually edible geometry. So when generative design finishes the process, it gives you, up to hundreds of different variations. You can easily filter down, so maybe you get down to like 8 different, outcomes you look at, you think is kind of interesting. You can bring those back into your design workspace and you can modify them, right? Like you actually have sketches, you have extrudes, if it's the organic shapes, you even can still modify them with T-spline technology. So it's not that generative design gives you the final, best man, potentially kind made part. It gives you suggestions that you can then take and you can then modify them and still make them your own, still, tweak them. And then of course with Inventor we have, Nastran. You can then take that design after you've modified it and again validate it with FEA and make sure that you're still within reason.
Thank you. Back to you, Kevin.
Yeah, no, thanks. I'm glad it was kind of a good setup for this slide, which was basically saying that regardless of my Claudius Peters example of it inspired them to come up with a new shape, and they were going to have their own manufacturing methods. To Lars's point, we also build in the manufacturing methods and constraints into the results. You can control that with some of these examples.
Yeah, and it's also a good transition to the next poll that we have, because we want to have a little bit of interaction here in the room, and it's about the manufacturing methods that you use for your products.
Yeah, just while we're having this one up here, I didn't realize there was kind of a limit to the number of answers. And so earlier during my collaboration question, one of the options I asked was, do you use carrier pigeon? So that was my terrible humor for the day. And then a few of these, we'll see if any of those made it through some of the polls after Anton filtered them out. Comic relief.
Yeah, Kevin, this is my fault. Yesterday I was laughing a lot about your jokes, but unfortunately I couldn't embed them into the polls because we can have 5 options only. That's it.
Fair enough.
We appreciate the humor as well. Keeps it
real.
real.
Just try to keep everyone on their toes.
Absolutely.
Okay, so those are some of the results.
All right. Well, hopefully you can see, those are all different things that we can accommodate with generative. So, give generative another look relative to that. So a couple additional things to wrap up the generative section. Next slide. So we showed earlier the Claudius Peters example. This one goes one more click down with our friends at MJK. They make performance parts for the motorcycle industry, aftermarket parts. And you can see kind of the human design version, heaven forbid, just a human design. And now we have the robots helping us for the other ones. And the robots are telling us that we can reduce cost or maintain cost, adjust safety factors, weight, and based on the manufacturing conditions. So obviously the third one is, or the fourth one is, the highest cost, but in each case we're able to reduce the weight and adjust the safety factor accordingly. So this is just a visual representation. Maybe this is a good screen grab to kind of inspire you to think about, what will be a new way that you try to apply generative to some of your parts.
Mm-hmm.
And Kevin, one thing I'd add there, the robot way, when you see the 2.5 axis version, that's one that you can still go in and in fact, all of them, it still provides you the ability to go in and tweak the results. You may want to change the wall thickness of something, open up a profile a little bit more. This is all sketch based, at least the 2.5 axis. Some of the 3 axis is profile based that you can go in and tweak. The other stuff, kind of the bone areas, you can go in through our T-splines capability, our form capability, and make adjustments there. So you still have flexibility to use your own creativity and your own experience to make adjustments as needed.
Yeah, there's tons of classes at AU that will get into a lot of the details that obviously if you can't attend them all, make sure you look at some of those classes. So this one's just for fun. We've talked about the robots.
And the jokes, right?
Oh, good, a joke made it in.
Yeah.
Would you trust AI to help you make better designs? And check all that applies. So all that apply might be interesting here to see how that goes. But you know, hopefully you're considering it, or maybe you do. Of course, it depends on what part you're making in the situation. Just a flat out no is okay. And the last one, for those with humor, no, I'm just kidding. Those that have seen the movie Terminator, maybe you would not let generative design participate in your designs.
So I have to give a shout out, Kevin. You were talking about classes. So Lars, who was just talking, he has a class called 7 Reasons Why Inventor Users Also Want to Use Fusion 360. So if you haven't seen that class, remember these are all online and you can watch them anytime. Make sure you check out Lars's class specifically for Inventor users to get started using Fusion 360. And I'm sure there's going to be a little generative in that class. I would guess there's a little in there, Lars.
All right, so just to wrap up this section, so I didn't get to cover all the classes, but I did want to pick one that's really into the depths with the product management team. So there's a class right there in the middle. If you are interested in generative and you haven't yet kind of gone down this path, go ahead and start a trial. Even if you have an entitlement to Inventor in the collection, you can go ahead and start a trial and get access to running some generative without necessarily consuming cloud credits. So take a look at the trial. We do have a protection to make sure people aren't abusing this system. So we'll know who you are if you're really trying to take advantage of the free trial and to keep doing real production projects. But get in there, give it a whirl, make sure you understand what's possible. The class that Mike and Ryan are teaching will be great. And just to re-emphasize, you know, Roger has some really great perspectives on generative and other things to check out on the Fusion blog.
Yeah, and also if you like the format, more conversational format, Q&A format, tomorrow, same time as today, we'll have the meetup for generative design, and we'll have Mike Smell, the senior product manager for Fusion 360, as well as other PMs live, ready to answer your questions. So you can register there from the main AU page in the meetup section. So same time tomorrow. Okay, so skill number 3, design automation. And this is where we would like to, of course, bring everyone into the conversation, but we'll ask Dave to lead this part. And, you know, there are a lot of ways and some of the pre-work that is required for automation. But Dave, why don't you lay out the landscape for this one here?
Okay, well, yeah, just we'll wait to the first slide. So you can go to the next slide. Everybody can hear me okay?
Yeah.
So I got to thinking, and I ask this question often. You know, what is iLogic? How would you answer that question? What is iLogic? And there's lots of different answers that I've heard. Some think of it as you know, it's an add-in for Inventor for building configurators. You know, check, you get a point for that answer, right? It's a tool for doing rules-driven design. I like that one. I'll give you a point for that one. It's a workflow automation tool. Seeing people use it for workflow automation. So yes, that's what iLogic is as well. A scripting tool intended for non-programmers to build simple automations in Inventor. I should probably put 2 points for that, but that's a good definition of what is iLogic. But the last one is my favorite. Well, because it's mine. And you know, I was involved with the original. Kevin calls me the godfather of iLogic. It's true. I was one of 3 guys that originally sort of came up with the idea and developed the technology, and that's how I ended up at Autodesk, actually. But this definition in highlighted speaks to what we were really thinking when we invented iLogic. for Inventor. It's a tool for capturing an advanced level of design intent beyond what we thought was simple parametrics, we called it, by means of defining and embedding conditional relational constraints into Inventor models. So, you probably wonder, well, what do you mean by conditional relational constraints? It's about defining those relationships between the properties, parameters, features, and components of a design that are oftentimes conditional. So this conditional relational constraint that we would think of a rule as describing is almost 90% of the time, it just involves simple if-then statements, right? That's the conditional statement. If this property is this and this parameter is that, then turn this feature off, turn this one on, add this component. So that's what we mean when we talk about a conditional relational constraint. And as such, that's why a rule is actually part of the Inventor document. It's contributing to the design intent and to the definition of the actual relationships between things in a design, so that if a change is made, you don't just have simple parametric equations firing to contribute to the update. You have actual conditional relationships being evaluated to express, sort of a behavioral update of the model. Anyway, I don't know if that helps or not, but just wanting people to understand a little better. iLogic is a lot of things to a lot of different people, but that is essentially what it is at its core. And with that in mind, who is iLogic for? Who we intended it for, was for every Inventor user, right? For every Inventor user. And what we see is that a lot of people are shying away from iLogic, or they misunderstand what it is, and they think it involves, complex programming that they don't want to get into, there are misconceptions, I think, that prevent people from sort of opening that box and giving it a try. But I just want to say that, there's very simple things you can do, and I think, and I'm going to show you live here, a conditional relational constraint is very simple, and I would say anyone can learn to do that with rules, conditional relational constraints. But we chose to use an actual commercial off-the-shelf programming language when we developed iLogic, and it's fundamentally VB.NET. So yeah, you can do these very simple rules that define these simple conditional relationships between things, but then also really no holds barred. Because it's VB.NET, you can certainly access the entire Inventor API and just use what we call as bare knuckle or bare metal Inventor APIs are fully within reach, and you can do all that you want in a rule using that kind of programming. But then really anything with VB.NET as a language. So depending on your programming prowess and your imagination, people do all kinds of crazy stuff that I never even imagined they would do with this simple notion of a rule that we had when we developed it. But I think there's something in there for everyone, and I just wanted to sort of encourage everyone, challenge everyone. If you haven't, cracked the lid on iLogic in Inventor yet, it's been part of the Inventor offering as basically a baked-in, no additional charge feature for more than a decade now. I think, what are we, 11 years old with iLogic? So I wanted to throw up an actual example. So BCK Holland. Oh, let's do the poll. Let's go ahead and do the poll.
Let's do the poll. The first question is about your experience with design automation.
Plus, what is, yeah. I think you changed the question, Anton.
Maybe a little bit.
I think it was, what is your experience with iLogic?
That's right.
Cool. Lots of novices, journeymen, few experts. Okay.
Yeah. This is one dimension. And another dimension that you mentioned about the programming expertise, right? Because it was intended
this would be like
for everyone.
if you're an iLogic user, what's your programming expertise? I should have been more specific with the question. So if you're one of those that use it in some way, shape, or form, what's your programming expertise?
Dave, I think you should have had another answer for whatever Paul Mumford showed me. That's been my level of experience with iLogic. I'm not sure if Paul's even on the call, but had to give him a shout out.
Okay, so very similar. It looks like similar relationships, ratios between lots of novice and the novice folks are my favorites. It's like we do simple stuff but meaningful stuff that makes magical things happen in our models. To use that word. So I'm going to share my screen now and just go live so I can make the point really clear, more clear about what I mean by conditional relational constraints and how essentially simple rules can be to do powerful magical things. Okay, so I'm going to show my screen here. It says show my, all right, show my screen. Which screen is it going to show?
You see a funny map.
That, by the way, is the best image ever created of a portion of a human cell. What does it look like? It looks like a computer chip board. Oh, that's the wrong term for that, isn't it? Or it looks like a city. It's amazing. How do I switch which screen I'm sharing, Anton?
Okay, let's try to do it one more time. I will change the presenter to, okay.
Stop showing my screen. It won't let me stop showing it. It's not giving me a choice of which screen to show. Here we go. Should have practiced this. There we go.
Yeah, Dave, and yeah, we can see your
See it
screen.
now.
Yeah, and
Awesome.
yeah, let's just make sure that we leave enough time for the last topic.
Yeah, sorry, I'll go quickly. So this is a simple configurator built by a company called BCK Holland, and they build conveyance systems. And this little iLogic configurator has its own form, so we can come in here and configure the conveyor width and its length and lots of different options they've baked into here. And you would think that it would take a programmer to put together this kind of configurator, but I would argue not. I would think anyone on this call could learn to do what they've done in building this configurator. The form, the iLogic forms, is zero code. It's just all drag and drop to create your own form. So we just updated the width and length there. But just to take a quick look at the rules, I'll take a look. There's a rule here that defines the support, when you have the support or not on the sides of the conveyor. So if I open that rule, you'll see that in terms of code, actual programming, you're afraid of programming, it's almost exclusively if-then statements. So if the support is none, component is active, turn a component on or off. If the support is this name, then in the parameters, this value, change this parameter to that, change this parameter to this, turn some components on and off. Again, more just evaluating a parameter's value and changing other parameters, doing a little bit of math, adding and subtracting, sort of suppressing and unsuppressing components. All of the rules, there is nothing else in all of the rules in this model besides changing properties, parameters, suppression states of features and components, and modifying parametric equations. That's all there is. All right, so this same model, by the way, can also be uploaded. Let me just switch my active screen here. I'm also product manager responsible for design automation on Forge, Inventor on Forge. So we can take this same iLogic model, and what I'm showing you right now is actually a demonstration application that we provide all the source code to for anyone that wants it. And basically, you can take an iLogic model and upload that iLogic model into Forge, into this sample app, and you can modify its parameters and update it. The parameters panel is auto-magically built by extracting the key properties, key parameters, and reading some of the form definition from the desktop model. It's got the Forge viewer embedded. It's going to take a minute here to update. Just bear with me. It's actually round tripping right now with Inventor on Forge. How are we doing for time, Anton?
Well, it's almost time to give it a go to the last topic. So.
Okay.
Yeah.
We'll just give this a second then, and I'll wrap up.
Yeah.
And then I want you to put my second slide up quickly. I think I have bandwidth issues because of the meeting, perhaps. So my apologies. There we go. So processing time for that was 35 seconds. I updated the wheel. I can look at the bill of material. We can look at the drawings. This is all in a web-based application. It's basically taking the iLogic model and running it on Inventor server on Forge, generating the outputs and then feeding them back as in viewable format to the Forge viewer. And then the outputs can be downloaded, which I'll show you in a second. We tested all this in advance, and it was much more performant than it is right now for me, unfortunately.
Hey, Dave, I wonder if we move on because we have a hard stop at the bottom of the hour.
Okay, just throw the my last slide up, Anton, please.
Okay. Let me go back to the slides, and I'll go full screen. Last topic. You know, I think that the slide disappeared magically.
Really?
Dave, no luck. Yeah.
My slide about Forge is gone.
Yeah.
There. This should be the next one.
Yeah.
Okay.
That,
well, there you go.
Yeah, technical glitches.
There is a slide about what is Forge, and there's a link in there to the video that'll give you a 1.5 minute education on all about what is Forge, and also there's some links for you to find where the source code is for the Inventor on Forge demo app that we built, where you can download the source code and do your own deployment of that. Anyway.
Yeah, and this will be provided as a follow-up, so we'll send it out. You'll find in your inbox this presentation with all the resources that we covered today.
Great, thank you.
Sorry for the technical glitches. And yeah, let's move on to the last one, design for manufacturing. Karen, so we've got a few slides, so could you help us to lay out the landscape of the world here?
Yeah, I think we'll do kind of a fast forward through this, but you know, as we look at, I think kind of looking at the history of Inventor, you know, we just hit 20 years last year. We talked about it at AU, but you know, over the years we've built in a lot of capabilities in the product to help for design for manufacturing. You know, is this a sheet metal part? Is it a plastic injection molded part? You know, we've started to add things like MBD tolerance analysis. We've had simulation in the product. So you think of a small example like this, where it's this is a concrete leveler, and you know, quite a few moving parts for a little assembly. A lot of things that you'd need to take into consideration: weight, strength, overall durability, how it's manufactured. As I mentioned earlier, is it sheet metal? Is the shroud a plastic part? So you know, thinking about all of those things, and then being able to design and manufacture those. So you know, I think that kind of tips off kind of where we're going with this. I know you have a slide, so maybe we hit the slide real quick and we'll jump into a few of these areas, or not. Did you have a slide that you wanted to hit, or do we want to skip past that?
Oh, can you, do you mean the poll?
Yeah.
Yeah, we can hit the poll, so we can totally do that. And let's launch the first one about who does CNC programming in your organization.
Yeah, so a couple areas we'll hit on, some of the CNC side, and we're always interested to understand, are you doing mostly design work, and then that gets that's provided to a different group that's doing the CNC programming, or do you do both programming and design work? Great. Okay. Very good.
And the other one is.
Yep, and then from the collection, what products do you use? I think there's a bit of an assumption here that Inventor is kind of a given, but then from the collection, what else do you use from there? Do you use Inventor CAM, Fusion 360, some of the MBD tolerance analysis capabilities, nesting, and then in the collection there, a handful of other products, AutoCAD being one of those. All right, very good. All right, thanks for doing that quickly, and then we'll kind of wrap this up. I know you guys probably have some other sessions that you want to jump into. So if we can go to this slide, so looking at how we may break out some of these things, top left, an example that we did about a year ago, we took that little black part. It's kind of hard to see, a little yoke. We took that and had it, we had tolerancing and various information in there. And basically at a pretty high tolerance, we sent this over to Xometry to get costed out. They have a host of manufacturing shops that bid for jobs, and they came back with a quote to make that part. It was about $1,100, fairly tight tolerancing. So we ran that same part through tolerance analysis, loosened up some of the tolerances, but still fit within kind of the expectation of how it would function, and drop the price down to a little over $600. So about half the price to manufacture the part that would give us the same end result, but we were holding much higher tolerancing than we really needed to. So looking at tools like tolerance analysis and our MBD capabilities to look at parts, maybe make a little more intelligent decisions on, is this something that I can loosen some tolerances and cost less, or do I need to hold it to very tight tolerances, knowing it's going to cost me a bit more, but as it stacks up, I need those tight tolerances. So tools like that, we have simulation type of tools that allow us to test for strength, even looking for resonant frequency and making sure that this little polisher isn't going to walk itself right off the job site. Keeping it lightweight, we needed to keep it under 80, 90 pounds to be able to lift it up, put it in the back of a truck. So, being able to lighten it where you can. As we think about design for manufacturing, all the sheet metal components need to be nested and manufactured. So how can I easily first determine if it's a sheet metal part versus a weldment or an injection part? And then from there, how can I set these up for manufacturing? How can I collect all the similar thickness parts, nest them, and generate G-code or send that over as DXF? So these are all the type of tools that have been built into Inventor over the years. Many of you use a number of these. We find that a lot of customers aren't familiar, aren't aware that they have entitlements to use these today. So if any of these sound of interest to you, it's likely that you have access to them. If we can go to the next slide. This is just an example. Many of you, we've talked to a host of folks that you're engineers, you go through school, oftentimes you go through the tolerance stack up and figuring out kind of how this all plays out and utilizing Excel to manage all of this. And yet, oftentimes we just do it in our head. We're just making kind of some assumptions and do what we can in our head and move on. But there are tools that can help you, so you're not having to try to manage all these stack ups and things in your head. This is just a common shaft that would get tolerance stack up across the board here. It's pretty hard to looking at this knowing that it's going to fit accordingly, maximum, minimum, tolerancing, see what kind of issues you may run into, what parts are gonna have conflicts. So being able to utilize tools for that. Next slide. And then I think we'll skip this. This is a little video that we've had. This is one you can get out on YouTube, but it basically just shows the tolerance stack up, the capabilities, some of the options you have with tolerance analysis. So I think overall, just looking at the capabilities that we have in the collection, tools that are in there for design for manufacturing today, and then looking at things like CAM workflows, we have a pretty rich set of capabilities that allow you to take an Inventor part, do a setup in there, and generate your G code and work from there. We're also working on tighter integration between Inventor and Fusion. So we know many of you work with job shops, and a lot of the job shops have used Fusion 360, and more of them are starting to use Fusion 360. So looking for ways to make it easy for you to collaborate, share your data from Inventor over to Fusion 360. So that's some research and some things we've been working on, but you have Inventor Cam today, and then if you're collaborating and working with other folks using Fusion in the future, that will be easier and easier over time. So then that kind of takes us into what's next. If we look at the future, oh, Andrew, I won't jump over that.
Yeah, so I wanted to just ask Andrew to quickly share a couple of words about his little project that he did in both Inventor Cam and Fusion Cam. Andrew, since we have limited amount of time, do you mind mentioning about a couple of words about the real project?
Sure. It was over a 2-year period. I started this thing off in Inventor, and I surprised myself when I realized that I was machining this thing up and I needed parts. I was actually in a guitar shop, and I was asking them if they had a blank for the bone nut, which goes at the end of the neck. And then I suddenly realized I don't actually know what size I need. And I was like, wait, I've got Fusion on my iPhone. And I opened up the whole model on my iPhone and measured the sizes of the blank that I needed, and I could take home the correct one. So it just completely blew me away. I didn't realize how useful that was, to have the ability to see, my data on my phone. I thought it was a pretty useless exercise, but once I'd used it, I was like, wow, this is just invaluable. Wished I'd had this when I was a manufacturing engineer,
Yeah, and that's the final result. Congratulations, Andrew. Great project.
Thank you.
Yeah. All right, Karen, back to you in terms of what's coming next with Inventor. And yeah.
So I'll give you the shotgun approach here. We did add a new roadmap out on our Inventor blog that will help you guys out. I just took a screenshot of this, but as we look at what's next, there's a lot of really great things coming. Things like model state have been a highly requested feature from many of you, to be able to create configurations and store all the configurations in a single file. Things like simplification, we've continued to enhance the simplification capabilities, and that also rolls into some better Inventor Revit interoperability. Also enhanced some automation capabilities, looking at things like modernization. You'll see some work that we continue to invest in modernization, not finalizing, but wrapping up dark theme. We had a preview last year, and bringing that into full-fledged, out of preview into the product, fixing some areas based on feedback, and then the home screen now is fully dark theme. Over a point release, we added it to iLogic. Fillet is getting an overhaul with overall user experience and in the new property panel. So these are just to name a few of the things, but go check out the blog post. If you're not part of the Inventor beta forum, a lot of that will be new to you. If you're in the Inventor beta forum, you've probably been in some sessions, provided some feedback, and chatted with us already. But those are just some fun things to come. Dan could take the next hour or two talking about some of the customer success things that his team has worked on that are a lot of, we call it just do it, but a lot of the things that you guys request that, we like to look at them as the death by 1,000 cuts, those things that maybe just drive you a little crazy every day as you're using the product. We try to smooth those over, clean them up, fix areas that you may struggle with, and Dan's team has spent a lot of time, working on some of those as well. So I think overall we're really excited for what's coming next. You know, go check it out. We always like feedback. We're always looking to hear from you guys, what you like, what you don't like, and provide that feedback to us. So I know that's pretty quick, but yeah, best, I think, yeah, I have the URL bottom right, so blogs.autodesk.com/inventor. I think it's the second one there now. You can just see the Inventor roadmap and take a quick look.
You could also attend or watch Garen's class looking into the crystal ball, the future of Inventor, where he basically does all of that in about 36 minutes and 45 seconds.
Yeah.
Thanks, Luke. I appreciate the plug.
No problem.
Yeah, so we covered the 4 skills, and I'd like to return the microphone to Kevin. Kevin, do you want to wrap up the 4 skills?
Yeah, I just think just in general, you know, those 4 skills were some things that we highlighted as areas that we believe many of you could kind of take it to the next level. If there's other skills that you think this panel or others at Autodesk can help you with, you know, shoot us a note. We'll try to get you into the best contact, either in our partner network or at Autodesk. That's really it from a 4 skills perspective. We just want to make sure everyone, we use this venue to have kind of an open dialogue. There's a lot of great chat. We're going to follow up with some folks there. Yeah, that's it for the 4 skills.
Yeah, and in terms of next steps, you will get the recording of this class as well as the clickable PDF of the slides that we covered today. So please take a look at those resources, especially pay attention to other classes, meetups tomorrow, and also check out the group network if you really like to be a part of the community or you want to start leading a community. And with that, I'd like to thank our panelists today, and of course, all of you for joining the session. Huge thanks, and I hope that you enjoyed this AU, and there is a lot of you know, great sessions that are coming up later today and next 2 days.
Just one thing, Anton, real quick before we wrap. So I posted a little trivia question in the chat. So the first 3 people to email me the answer to this question: which 2 presenters from yesterday's general session or keynotes are former Inventor product managers will receive one of these 20-year mugs for anyone who doesn't have one of these already. So I'll mail that out to you. So we got 3 of those to give away. So great question. Just email me at kevin.robinson@autodesk.com. And also just want to thank everyone for being customers of Autodesk. Thanks for being users of Inventor. And everyone here that's on the panel today, you know, we're always excited to hear from many of you. So don't hesitate, don't be shy, reach out and just let us be part of the community that you're all building.
Thank you.
All right, thanks everyone. Have a great day.
Thank you.
Thanks.
Take care. Bye.
Bye.
Have a great AU.